All right, so this is section 4 of chapter 3, and we're going to be looking at exponential and logarithmic equations. First off, let's look at a formula here that we have. If I have the same base here and they're raised to powers, then that means m and n both have to be equal. So as a really easy example, if I have 2 to the power of x equals 2 to the power of 5, well, then x has to equal 5. When we're solving exponential equations and logarithmic equations, we want to make sure that we're always checking our answers. We may have answers that when we plug them back in don't actually work. So let's go ahead and dive in and get into some of these problems. This first example here, I have base 5 to the power of 3x minus 6. And looking at what I have on the other side, it kind of suggests that since this base is the same, and I probably want to try and use this formula, then I can rewrite 125 as 5 cubed. Well, now we have the same base, so that means my exponents are equal. 3x minus 6 equals 3. Adding 6 to the other side, dividing by 3, x is equal to 3. If I plug it in, let's check and make sure that it works. Plugging in 3, we have 3 times 3 is 9, minus 6 is 3, 5 to the third power is equal to 5 to the third power. So that one works out. Looking at the next one here, I actually need to change this real quick. This should be a 4, not a y. So we have 4 here to the power of x minus 3 and 8 to the power of x plus 2. Now, we can't write this in base 4, so that isn't going to work for us. But both 8 and 4 can be written in base 2. So I can rewrite this as 2 to the third power times x plus 2 equals 2 to the second power times x minus 3. And when we do that, distributing, and now we have the same bases, 3x plus 6 is what this becomes, is equal to 2x minus 6 is what that becomes. Well, when we solve that, subtracting 2x, subtracting 6, x is equal to negative 12. And for the sake of time, I can tell you that that's going to work out. If I plug in, let's see, negative 12 right here, negative 12 plus 2 is negative 10, times 3 is negative 30. Plugging in negative 12 here, negative 12 minus 3 is negative 15, times 2 is negative 30. 2 to the negative 30, 2 to the negative 30, this checks out. All right, now looking at the next one, we're probably not going to be, and I can tell you for sure, we're not going to be able to write these in the same base. So now we've got to start thinking about what other tools do we have. And one of the things we're going to be able to do here is take the log or take the natural log of both sides of our equation. Now, just because in calculus we use natural log a lot more, I'm just going to go straight to using natural log here. We have natural log of both sides. And so natural log of 5 to the power of x equals natural log of 134. And using the power rule in the properties we learned in the previous section, that x can come out front. Okay, so now we have x equals, or we can divide by natural log of 5 here. And we have x is equal to the natural log of 134 over the natural log of 5. That is our exact answer, but we want to plug that in our calculator and get a rounded answer. So we have natural log of 134 divided by natural log of 5. And we get 3.0431. We'll round to 4 decimal places. So 3.0432. Okay. All right, so let's go ahead and try another one. And in this case, I'm actually going to use just regular log. And the reason why is that if I just use a regular log, then I can still use my calculator, and regular common logarithms are already base 10. So log and log, and now we have log base 10 of 10 to the power of x equals log of 8,000. Okay. And what we can do here then is bring that x out front. Log base 10 of 10 is just 1, so we have x is equal to log of 8,000. Okay. So that's our exact answer. I can plug that in my calculator and get my rounded answer. And I get 3.903. We'll leave it at that. 3.9031. All right, let's go ahead and do this last one here. We have a couple steps before we can start taking the log or natural log of both sides. Right now I have some other numbers on this side, so I need to add 3 to both sides and divide by 40. So when I do that, I get e to the 6x, and adding 3 gave me 240, and then 240 divided by 40 is going to give me 6. So now I'm going to take the natural log of both sides. The reason we're using natural log is because we have base e. And that 6x is over here, comes out front. Natural log of e is just 1, so I have 6x is equal to natural log of 6. Dividing by 6, x is equal to the natural log of 6 over 6. And then we can plug that in our calculator, get our exact answer. Natural log of 6 divided by 6.2986. Okay, so again, in my answers, I'm including the real part, or the exact answer, and my approximate answer. Let's go ahead and flip the page here. Look at a couple more examples. Number 6 here, we have 5 to the power of x minus 2, and y, I'm sorry, we're going to change that to a 4 again. I'm not sure why my 4's all turned into y's, but 4 to the power of 2x plus 3. Okay, so right now what we're going to do is we can take the log or the natural log of both sides. Again, because in calculus we will use natural log more, I'm going to go ahead and just use natural log. So we have natural log of both sides. I can bring that x minus 2 and the 2x plus 3 out front. I'll go ahead and zoom in a little bit here. Okay, so those exponents are coming out front. X minus 2 natural log of 5 equals 2x plus 3 natural log of 4. And it's really important that we use parentheses here, because this ln 5, or natural log 5, really just represents a number. So that needs to be distributed into what's in the parentheses here. So distributing, I have x natural log 5 minus 2 natural log 5 equals 2x natural log 4 and 3 natural log 4. Now our goal here is to solve. That's what the directions said. And solving means solve for x, get x by itself. So I'm going to get all of my terms with an x on one side and the rest of my terms on the other side. So subtracting 2x natural log 4 minus 2x natural log 4, and adding 2 natural log 5, adding 2 natural log 5. We can't combine any of these terms. This one cancels and this one cancels. So I have x natural log 5 minus 2x natural log 4 equals 3 natural log 4 plus 2 natural log 5. And we still haven't solved for x yet, but I noticed that both of these terms have an x in common. So I'm going to pull out that common factor. And then this now has no variables in it or anything. It just represents a number value. So I can divide both sides by that, and I have x is equal to 3 natural log 4 plus 2 natural log 5 over ln 5 minus 2 ln 4. That's my exact answer. My approximate answer is going to be, when I plug this in my calculator, and I'm going to show you how to plug this in because it's going to be really important that you use a lot of parentheses here. So looking at this, I'm going to go ahead and clear. I'm going to use parentheses 3 natural log 4 close parentheses plus 2 natural log 5 close parentheses, and that's my whole numerator, divided by parentheses natural log 5 close parentheses minus 2 natural log 4 close parentheses, and I get negative 6.3429. And that's my exact answer. Okay, let's go ahead and continue working through these problems. Looking at the next one, this problem I've noticed kind of follows a quadratic pattern. We have e to the 2x, e to the x plus 7. And we're going to do something called a u substitution. And this is a tool that you'll use in calculus. If we let u equal e to the power of x, then this would be u squared minus 8u plus 7 equals 0. We just did a substitution. And this is something that you know how to solve. You know the x method or whatever factoring methods you prefer. And factoring this gives us u minus 7 and u minus 1 equals 0, u equals 7, and u equals 1. Well, we're not actually interested in u, we're interested in e to the power of x, or solving for x. So I'm going to write the equations that these actually are. It's e to the power of x equals 7 and e to the power of x equals 1. Well, e to the power of x equals 1, x has to equal 0 because anything to the 0 power equals 1. That's the only way to get 1. E to the power of x equals 7, we can take the natural log of both sides, and that's going to give us x equals natural log 7, and when we plug that in our calculator, we get 1.9459. Those are two answers. All right. Now let's go ahead and look at this next one here, and I'm going to use the Snail Rule that we talked about in the last section. I have 2 base 3, so 2 to the power of 3 equals x minus 4. And 2 to the power of 3 is 8, and then adding 4, so x equals 12. And I haven't been checking my answers, but let's go back to doing that real quick. If I'm checking my answer here, plugging in 12, 12 minus 4 is 8, and there's not a problem taking the log of 8. But if we had gotten a negative 8 in here, that would be a problem. We cannot take the log of a negative number. All right, so we checked that one, it worked out. I'm going to go ahead and stop here on this video because it's about to run out of time, but I will do a part 2 and finish these last couple examples.